Okay, now we're going to be taking a look at derivatives of inverse hyperbolic functions. So as you can see here, the rules are given in this table. We're going to apply them. The important thing to do, though, is to remember that if you're going to be applying a power rule, which in the case of the square root of 11x we're going to, I need to rewrite this. So I'm going to write the Cinch inverse as the Cinch inverse of 11x quantity to the 1/2 power, because I'm going to need to use that in a bit. So what I'm going to do is I'm going to proceed to find my y prime, and in finding my y prime I'm noting this derivative rule here, and it's 1 over the square root of 1 plus u squared multiplied by du dx, which is of course the derivative of the inside. And so let's see what this looks like. 1 over, well, my u is this part right here. This is my u. So I'm going to say 1 over the square root of 1 plus, in this case, the square root of 11x quantity squared, multiplied by the derivative of u itself, mainly the derivative of this part right here, because we need to think about it in terms of exponents. So I'm going to have 1/2, let me switch pens here, I'm going to have 1/2, all right, of 11x raised to the power 1/2 minus 1, which is negative 1/2, multiplied by the derivative of the inside, derivative of 11x in this case being 11. And so that's pretty much it. It's just a matter now of cleaning it up just a little bit. And so we can examine the way that this looks. We have 1 over the square root then of 1 plus basically 11x, because the square cancels the square root, gets rid of it. And on the other side here, we have 1 over 2 multiplied by the square root of 11x multiplied by an 11 in the numerator. So we can put all of this together and we end up with something really nice that looks like this. 11 over 2, and then since both of these things are in the square root, I can say, well, 11x multiplied by 1 plus 11x. All right, really no need to simplify that. Okay, it's pretty much straightforward after that. So this is what this one looks like right here, the answer for that inverse Cinch derivative. All right, and let's go ahead and take a look at another example. And in this next example, all right, we're going to say y equals, and we're going to talk about theta. We haven't maybe talked about theta in a while, but it's the same thing as x, if you will. And we're going to multiply this expression here by the tanh inverse. So we're going to need the rule for tanh inverse. And we should start recognizing that this right here is going to be the case of the product rule. So a nice product rule example that involves the derivative for the inverse tanh. All right, so let's take a look here. We've got our u and our v. And so if I write out u equals theta square plus 5 theta, and v equals the tanh inverse of theta plus 4, I can find my u prime very quickly. This is 2 theta plus 5, straight up power rule. The v prime, a little bit more challenging, but we've got this table that we can reference. So we say then it is 1 over 1 minus u squared du dx. Okay, so this one is actually not terribly difficult, but let's figure this out together. I'm going to say then I have 1 over 1 minus, and in this case my u being theta plus 4 quantity square. Okay, so I have something that looks like that right there. All right, and now I can actually expand the denominator. I can say it is 1 over 1 minus, now this right here is a binomial squared. So if you know the rules for binomial square, you know that it's theta square plus theta times 4 times 2, which is 8 theta, not h, sorry. I'm thinking about limits. 8 theta plus 16. So it looks something like that. You can combine like terms again. You get 1 over, and this is what makes this one a little bit longer. 1 over 1 minus theta square minus 8 theta minus 16, which we can continue to combine like terms. We get negative theta square minus 8 theta minus 15. We can factor out the negative 1 there. Alright, we have in the denominator then theta square plus 8 theta plus 15. And I think that we should just go all the way with this in terms of the factoring component. And that is just to quickly write it as negative 1 over the factors of 15 that add to give you 8 are 3 and 5. So theta plus 3 and theta plus 5. So we may see that that may prove beneficial to us when we continue with this, but let's go ahead and see if it was futile or if it was useful. All right, so let's see here. We have u v prime. So v prime we've definitely got. We know u is theta square plus 5 theta. And let me actually bring this down just a little bit. Theta square plus 5 theta multiplied by negative 1 over theta plus 3 times theta plus 5. Okay. Plus vu prime, which is going to be your tanh inverse, multiplied by 2 theta plus 5. So let's just write the 2 theta plus 5 first. And we've got our tanh inverse of theta plus 4. All right, there we go. So now, can you clean it up? Okay, that's the real question. And the answer here is that yes, there's something you can clean up. Okay, so if you consider that theta squared plus 5 has a greatest common factor. So let's rewrite this, and let me write it in a different color so that you can see. Theta square plus 5 is going to be theta times theta plus 5, just like that. Well, in doing that, let me cross this out. You should see that the theta plus 5 eliminates itself, okay, in the numerator and the denominator. The theta gets multiplied by negative 1, so you end up with a negative theta over theta plus 3, plus you have a 2 theta plus 5 multiplied by tanh inverse of theta plus 4. Okay, so this right here is your y prime, your derivative that you were looking for. Okay, and you know, some simple rules based on product rule and things like that. Really, this problem was more algebra than anything, but I think we should take a look at yet one more example of these inverse hyperbolic trig rules, and maybe then you'll get the hang of it if you haven't already. So let's take a look here, and we're going to call this one number 12. So on number 12, we're going to take a look at y equal Cinch inverse of the natural log of x. Okay, so again, another kind of chain rule problem, but nothing terribly difficult. We need to know then the rule for Cinch, and so let's bring that up real quick. The rule for Cinch was this one: 1 over the square root of 1 plus u squared du dx. So to find y prime, then I'm going to say, well, that's not terribly difficult. It is going to be 3. Okay, wait. There's a 3 missing. I'm sorry. It's 3 Cinch inverse of the natural log of x. So it should be 3 times. Now we have the 1 over, and since this was our u, we have 1 over the square root of 1 plus the natural log quantity here squared, multiplied by the derivative of the inside the derivative of u. In this case, derivative of natural log is 1 over x. Okay? And so really there's nothing to it. It's just a matter then of just cleaning it up just a little bit, because there's not much more to simplify. So you end up with something that looks like this. 3 over x times the square root of 1 plus the natural log of x quantity square. And so this right here is the answer for this problem here. All right, so really nice applications of the inverse hyperbolic function rules here, the derivatives anyways of inverse hyperbolic functions. As always, I hope this video is helpful, and remember, like and subscribe.